Integration is one of the fundamental concepts in calculus. What inspired the origin of this concept? Why do we call it the antiderivative? And how is this related to area? Curious to know this and much more? Well, watch the video to find out. Our objectives are to learn the concept of integration, to understand the meaning of general solution and a particular solution of the differential equation. We have learnt that differentiation gives the rate of change of a dependent variable with respect to an independent variable. We have also learnt to find the derivatives of functions. Differential of x raised to n with respect to x is equal to n x raised to n minus 1. Differential of sin x with respect to x is equal to cos x. Differential of a raised to x with respect to x is equal to a raised to x log a, etc. We usually know the relationship involving the rate of change of a dependent variable with respect to an independent variable, but we may need to know the direct relationship between the two variables. For example, we may know the velocity of an object at a particular time. We may want to know the position of the object at that time. To find this direct relationship, we need to use the process which is opposite to differentiation. That is called integration or anti-differentiation. If we know the rate of change of the dependent variable with respect to the independent variable, can we find the function relating the two variables? The process of integration is used in many applications. The Petronas Towers in Kuala Lumpur experienced high forces due to winds. Integration was used to design the building for strength. The Sydney Opera House is a very unusual design based on slices out of a ball. Many differential equations which refer to one type of integration were solved for the design of this building. The wine cask would be another example. Historically, one of the first uses of integration was in finding the volume of wine casks, which had a curved surface. Other uses of integration included finding areas under curved surfaces, movement and center of mass, displacement and velocity, fluid flow, modeling the behavior of objects under stress, etc., etc. Integration was initially discovered not as the reverse of differentiation, but as a process of summation. The notion for integration evolved from the summation approach. In this session, we will study the integration as the reverse of differentiation, and the function that we find is called antiderivative. To understand the process, we consider an illustration. We know that the velocity of a body increases with time as it falls vertically downwards. That is, the rate of change in velocity is equal to acceleration due to gravity, which is a constant. That is, dv by dt is equal to g, which is a constant. Here the question is whether we can find an expression which may give us the velocity of the body at a particular time. This will involve
మీరందరూ వీడియో చూస్తున్నారు ఫ్రెండ్స్, అలాగే సబ్స్క్రైబ్ కూడా చేసుకోండి ఫ్రెండ్స్, అలాగే షేర్ చేయండి ఫ్రెండ్స్. ప్లీజ్ ఫ్రెండ్స్, షేర్ చేసి లైక్ చేసి సబ్స్క్రైబ్ చేయండి ఫ్రెండ్స్. థ్యాంక్ యూ ఫ్రెండ్స్.